Hello and welcome to the Dockyard Elixir Roundtable, where the tables are generally round. We're glad to have a lot of new faces on the show today and new voices. So I'm going to let everybody go around and introduce themselves.
Hi, I'm Al Imhoff. I'm a principal software engineer here at Dockyard.
Hey, I'm Zach Liss. I'm a senior software engineer at Dockyard.
Hello, I'm Adam Phillips. I'm an engineering manager here at Dockyard.
Hola, I'm Gustavo, and I'm a software engineer here at Dockyard.
I'm Mike Benz. I'm a senior software engineer here at Dockyard.
Hi, this is Rockwell, also a senior software engineer at Dockyard.
Hi, I'm Benny. I'm a software engineer at Dockyard, making the transition from JavaScript to Elixir.
Awesome. One of the things we want to talk about on the show today is a Nerves project that Rockwell actually has done that is super cool. We need to figure out a way to put this in the show notes because you've got a page where you have screenshots of it and everything. But do you want to just lead off and give us the basic rundown of what it is that you built?
Yeah, absolutely. So this is a project that it's not technically a Nerves project, and I want to get back to that. But this is a project that I had seen a lot of, I'd see done in other ways, and I kind of wanted to just do it myself in Elixir because that's what we do here. This is called a METAR map. And what it is a physical map that it's like framed, you can hang on your wall, and there are LEDs embedded in the map. And what they do is they represent the different weather at airports all over the country or region or whatever. And so depending on the weather at the airport, it'll be green if it's VFR, good weather, blue, red, and purple, depending on different conditions like the clouds and ceiling and precipitation and stuff like that. So it's just like a fun thing to have on your wall. I'm a private pilot, aviation enthusiast, and so it's cool to just kind of a broad picture of the weather that's nearby and in a way that's actually useful to me as well. So I look at that, have that on my wall here hanging, running pretty much 24/7. So that's been cool. People have done this a lot before using I think the one that I saw before was just a single file like Python script, right? This information is readily available online from the FAA, just a CSV or JSON file or whatever you can download and parse that. But I just kind of thought I could do it better. And so this is the Elixir server implements that, and it has a ton more features as well. I'll post some pictures. We'll put some pictures in the show notes of the build process and also the source code because it's open source. What it is running on, it's running on a Pi 0W, which is a very, very stripped down Raspberry Pi, single core, very, very slow and kind of a pain to develop on, if I'm being honest. It uses a string of controllable LEDs called WS2812s. They are a very popular LED product that you can use to do all kinds of cool LED things. Like you can make big LED displays. You can make people make these cool like 3D hypercubes that have animations and stuff. And they're just extremely cheap. They come in all different voltages, and they're perfect for this project, especially because there's a library called BlinkChain, which was written by Greg Mefford, and he was very instrumental in helping me figure this stuff out. And it's this great Elixir library that allows us to very, very easily control these LEDs just from the regular GPIO pins on the Raspberry Pi. So that basically made this whole project possible. The project itself... Sorry, go ahead.
Those LEDs, so people that are listening that don't see the pictures, it looks like you can make them at least 4 different colors at your however you want to, and you can control the brightness as well. Is that right?
Yeah, so each LED, each individual LED, it's really interesting. It has 3 different colors in it. It has a red, a green, and a blue LED. And then you can basically generate infinite colors by doing any combinations of those 3, right? So by controlling the RGB, you could control, if it's fully white, all 3 are on. If you want purple, you turn on the red and blue and so on. So each LED can do many different colors. And they each individually have, you can control them individually as well, right? So you can say turn LED 3 to this color, right? And they serially connect to each other. So you send a message in it. Greg called it squirting. It squirts the data down the line like serially, one LED at a time, and it passes them along until it gets the LED it's supposed to.
So the LED, so if you want to send a message to LED number 5, it passes through 1 through 4, and they're just like, yeah, that's not for me, and they send it down the line.
Exactly. Yeah, it's just, I think it's 3 wires total. It's a power, a ground, and a data line, and that's it. That you can buy them in strings of like 50, and you just, if you want more, you just hook them together. You can get, many multiples of that before you start to run out of power.
Yeah. The map really looks beautiful. This is the region that you're in, you said? What area is this roughly?
Yeah, this is the Northeast. So I'm in Connecticut, and it's, oh yeah, I've got it pointed there. Oh, did the cat turn it? Is that what happened?
I thought you did that for our benefit.
Yeah, so the LED is of the Northeast. I've got, like, you can see JFK, you can see Boston, you can see up into the Catskills in New York, that kind of area. Okay,
cool. And what's the refresh on this? Like, how often are you getting data and updating it?
I think I update once per minute, and yeah, the data doesn't change very frequently. Technically, the METARs only update basically at the top of the hour for most airports, so that's usually when the data comes in.
Okay, so are you actually like looking at this map and be like, hey, I'm gonna go out flying this afternoon, I think. Okay, yeah, maybe not because the wind is too high or something like that.
Yeah, exactly. Yep, 100%. And in fact, I made it so that wind is not really a factor in terms of like how good the weather is, but I still wanted to represent that on the map. So if it's windy, the LEDs will sort of flicker, kind of like those LED candles or something like that to kind of indicate that it's windy.
That's so cool. I have a project that I made that's actually in the Dockyard blog. That I made a lullaby player, and I did use nerves in that case. But I use that every day with my kids. Like, we put them to bed at night, and it's like, all right, good night. I push the little button and it plays some lullabies for like, I don't know, 30, 40 minutes. I forget what the timer's set to, but then it turns off, so it's not playing all night. And there's just something really satisfying about having a physical thing that I made that I get to interact with every day, and it just works. So I kind of imagine that, like, every time you come in your office, you see that map and you're like, ah, I love that. That's mine.
Yeah, it's it's one thing to, like, get pixels on the screen, and we do that all day, right? But it's cool to, like you said, have the physical thing for sure.
So had you done any hardware projects before, or was this your first one?
I have done some hardware projects before. I had a similar project many years ago where I found an honest to God traffic light, like at a flea market. And so I have that controlled using a Arduino. Just, it has a little it's in my garage actually, and it has a ultrasonic distance sensor. So as you pull in the garage, it like slowly changes from like green to red, so like where to stop the car.
That's amazing.
Yeah, that was a fun one too, and that's nice because it's standalone, right? It's just a microcontroller. You don't have to worry about having a whole operating system and stuff. Just starts right up.
You just made me remember that when I was in elementary school, in the lunchroom, when kids were talking, it would get louder and louder and louder, and they had something like that where the red traffic light would go red, and a buzzer would sound, and then everybody has to be quiet. It just occurred to me that, like, oh, there was some awesome nerd behind that. That's really cool.
That's really like some teacher with the switch behind his back, but you could totally do that with like a microphone.
Oh,
right?
Yeah, pay no attention to the man behind the curtain. That's right. Okay, so yeah, but that's really cool. So Oh, I had another question, but I was going to. Oh, so you didn't use nerves. What did you use? You were using an RPi, but what's sort of the software setup there?
Yeah, so it's literally just running Ubuntu whatever, and I just have it just running as a regular process in that once it boots up. My main reason for that was basically I just wanted to get the project done. You know, I didn't want to have to learn too many new things at once, and so I wanted to get the thing done and just in a way that I knew how. But I'm definitely like open to revisiting it because it's been about 3 years now, and it's just like I said, it's been running rock solid, and so I'm feeling pretty confident with how the code itself and everything. So I think it's definitely a good candidate to sort of try to use that excuse to learn nerves because honestly, right now it does take a while to boot up. You know, you plug it in, it just kind of sits there for several minutes as the operating system comes up, and obviously the security concerns and who knows with unattended OS upgrades when the thing's just going to randomly break, and then I'm going to have to figure out how to get into it and fix it. So I think it's definitely a good candidate for tinkering with that. I just haven't gotten around to it yet.
Yeah, the one that I'm my project has no connection to the internet, so it's like, what are you gonna do? But it does have some hardware control. Like I've got a little keypad. I took a numpad, a USB numpad, cheap $10 thing, and each button kind of mapped it to what I wanted it to do. You know, play, pause, go to the next album or playlist or whatever. Then like which timer mode I want to be in, because there's one for naps and one for nighttime. And then my wife did a really cool job of like painting like icons on all the keys with glow in the dark paint. So it turned out really nice, and it's really satisfying to push those buttons. On your map, do you have any like configuration, power switch, any other like inputs, or do you pretty much like plug it in and that's it runs like that?
So it does run by itself, but as I mentioned before, like I wanted to add some cool extra features to it that sort of validated needing to use Elixir. So it actually is running Phoenix on there, and it has a little web interface, so you can go in and configure it through the local LAN. You could control different like thresholds. You can control like LED brightness and that sort of thing. And also, it does have a light sensor as well. So the brightness of the LED scales to the brightness of the room. And so that's taken up in their GPIO pin. And so, in the nighttime when I'm in my, cave, it's not like blasting my eyeballs out. But yeah, the web interface was designed to be like the main way into that. And it's a nice benefit of, having Phoenix there. I can just do that. Yeah, Zach, what's up?
Yeah. So you're mentioning how it's a good candidate for revisiting, A, for nerves, and B, I'm wondering, over these couple of years, are there any new features that you have like thought of that you could be nice to have since you have all of Phoenix and your little interface at your fingertips anyway?
That's a great question. I'm actually pretty happy with it the way it is. Yeah, nerves would be the only real big improvement that I've really thought of doing.
Nice.
It has a couple different display modes, and some of those didn't come out great. So I'd like to maybe improve them depending on basically what kind of information you'd want to show and how you'd represent it. And some of the stuff just didn't really end up being useful. So I mostly have it on just the one mode the whole time. Like, for example, if you want to show cloud cover, like, what does it mean? Like, do you only show LEDs where the clouds are? Do you show all the LEDs, but like different colors? Like, little decisions like that I don't know, are kind of hard to figure out until you see it. Al?
If you really haven't updated in 3 years, you might have to watch out that the way you're getting the data from aviationweather.gov, it might have too old of a registry store, because it's not using the root cert that signs Let's Encrypt, but like a recent problem that's going to happen at the end of September is the cert that signed Let's Encrypt cert is expiring. And so everyone had to update Erlang for that version. And so I'm just thinking that like potentially your thing is so old that like it'll just stop trusting the .gov cert. I mean, looking at the chain right now, like weather.gov is 2022, and then like 2023 for DigiCert's SA2, and DigiCert Global is 2031. So you have a long time. But like that is the thing with like the data is old, not just like it may have security bugs, but like literally your certificate trust store, assuming you have Hackney or whatever you're using for HTTP access to actually check that the certs are good, it might stop working for that reason because you don't have that cert store update.
Wow, that's a really, really good call out. I'm gonna have to definitely look at that because I am using yeah, it is HTTPS. I think the quick fix would be like if they serve it over HTTP, like I would just use that instead because who cares? But
Right,
thank you for pointing that out.
You would have to have Hackney set up to be checking it, which isn't like a default thing. Like there's a default level and a like we are very secure level. And so like most of the client projects we're on, we do the very secure level, and this is very important. But like the default way won't necessarily catch this. But there's a blog post about it. It's come up on client work of warning them of like, hey, if we interact with Let's Encrypt sites, it's all going to break at the end of the month.
Do I also have the option to maybe just turn off cert checking entirely because
right, but it's an extra Hackney config, so it still require a software update for you. So like either way, you're updating the software. So whether you want to update Erlang, like there are patches for OTP 23, which obviously you're not on, right? Because it's so old. So 23 and 24, and if you go to 24, you need to upgrade your Phoenix version because OTP 24 no longer packs the deprecated PG2, and so the way PubSub works, it doesn't use PG2, it just uses PG instead, and OTP 24. So you need a Phoenix that can like handle that PG2's gone. Because when you try to run old Phoenix on OTP 24, it errors out saying it can't find PG2. And it's because Erlang decided to stop shipping it because it had been deprecated for a long time and they finally got rid of it.
Wow. Well, that's what I get for not touching it for 3 years, huh? Thank you very much. That's very helpful.
I wanted to ask, when you built the actual code behind this in Elixir, were there any like Elixir features that were particularly useful in what you were doing?
Sorry. Yeah, that's a great question. There were a couple of things that cool abstractions that where I was able to leverage OTP to make this really nice to do. The main one being that each LED is actually its own gen server, right? So there's the sort of like concept of an LED controller, which manages this whole sort of fleet of LED, gen servers, and then it can send messages out to them to configure their state. You can tell it to do animations and that sort of thing. So, but the process of having the isolation between like the light sensor, the thing that fetches the METARs, the thing that controls the LEDs, the LEDs themselves, right? These are all separate processes that are running the supervision tree. And yeah, I mean, you could do it in an object-oriented way, like it would be fine too. But it actually, if we're doing some of these animations, they're actually very CPU intensive, especially on a Pi Mini 0, which is very constrained performance-wise. And so actually having the beam, do that, do the management of those cycles for me so that everything actually still keeps running and doesn't grind to a halt. That was actually pretty nice because it's CPU. It's not CPU bound, it's IO bound because squirting messages out over the LED string is very slow. And if your animations are happening faster than that, or you're sending out too much information, things can get bogged down. So, but the beam just handles all that because it's all, everything's happening concurrently and asynchronously. So that was a nice side effect.
So you shoot off a bunch of messages saying like, change your color, change your color, change your color to all these different gen servers. And then you've sent that process, that message, and then it can do a blocking call to its piece of hardware to actually make that happen. But since it's blocking, the beam is just gonna like, okay, you're blocking, I'm gonna let a different process run.
Yeah, exactly. Yeah.
Yeah. Cool. Yeah, that's really cool. So what kind of animations do you have? Is it like a change sweeps across the map, or is it like the I don't know. I'm just kind of wondering, like visually, do you see like a wave of change going across the map when stuff changes, or is it kind of like we got new data and then everything like fades to the new color that it needs to have? Or
Yeah,
what is that?
it's exactly that. It'll fade in when the colors change. It'll fade between colors. When you change modes, the whole map will wipe like top to bottom to black, and then it'll wipe back in with the new mode.
Oh, that's slick.
That kind of stuff. Yeah, and the way I had to do that was like we know the lat long. I had to plug in the lat long of every station, so it knows like which LED is at the top, something like that, so it could work its way down.
Yeah, I was wondering how you had a coordinate system, but you have a built-in coordinate system.
Yeah.
Okay.
So.
Yeah, that's really cool. So when you have to when you do like a change, like I don't know, let's say a particular LED is red and you want to change it to blue, and you're going to fade colors in between. Do you have to actually tell it? Can you tell the LED? You probably can't tell it like fade from red to blue. You have to tell it now be slightly more blue, now be slightly more blue, now be slightly more blue, right? Like that.
Yeah. So I stole this concept actually from web audio, where with web audio, when manipulating sounds, you can schedule stuff in the future by giving it like a timestamp in microseconds. You say at this time, change your value to this in a linear fashion, for example. And so I kind of borrowed that idea for this. So there's actually a struct called a timeline that each LED keeps track of, and it's a stateless thing that you can reduce over, and it allows you to schedule transitions in the future. And then depending on what the current time is, it will interpolate between like two values basically. And so you can interpolate arbitrary things, whether they're color or brightness, that kind of thing. And so the timeline struct sort of encapsulates that and allows you to step through it, at whatever speed you need. You can, and if you can abort an animation if you want to start a new one. You can use different types of interpolation. Linear is usually fine for most things. So yeah.
So you tell all your LEDs, you tell all your gen servers like, okay, your new color is blue, and I want you to transition over this amount of time or something like that, and then it's going to take care of like the cycles of like sending itself a timeout to go to the next increment or whatever.
Yeah, exactly. It uses I think it's just as simple as process.send after. It just keeps sending itself messages to basically, tick over one frame every dozen milliseconds or so. That's
so cool. That's I love picturing in my mind like how that's happening in the processes. that sounds awesome. And also, I would love to see like a video of it actually doing this. That sounds beautiful.
Yeah. Another similar thing was for the light light sensor. So the way photodiodes or photosensors work is it's actually a photoresistor. So depending on the brightness of that it's collecting, it changes its resistance. And I forget the relationship exactly, but if it's bright, it's one resistance. If it's dark, it's different. And so what you do is to measure the brightness, you charge up a capacitor. Think of a capacitor like a battery. It temporarily holds charge, right? So you charge a capacitor, and then you drain the capacitor through that resistor. And depending on how bright it is, it'll drain really quickly or drain really, really slowly. And so what we do is with another gen server, we're periodically polling the voltage on that pin. And once that pin drops below a certain thing, then we know, okay, X number of seconds have passed. And then that lets you map to figure out exactly how bright the thing is. And so that's another, you can do it with circuits, but it's kind of weird to do it in code like this on a, scheduled operating system, but it does work well enough.
Yeah. How long does it take to drain that? Are we talking like a few milliseconds or like 10 seconds? Like when you turn the lights off, how fast can it react?
Yeah, it does a lot of averaging, right? To make sure it settles, but it takes a few seconds. We're pulsing it every 100 milliseconds, and then we wait 600 milliseconds for it to drain, and then we check it. So we're pulling it, I don't know, 2 times a second or so.
Yeah. It's actually kind of nice sometimes with things like that. If like animations, like if you do slow it down a little bit, I mean, if it happened, if it were able to do it in like 10 milliseconds, then you'd turn the lights off and you wouldn't see that it actually changed brightness. It's nice if you turn the lights off and then you see it go, ooh, down to the new brightness.
Yeah, it's working. It's like trying
Right.
to see if the fridge light closes when you close the door.
Yeah. Anything else that you found useful in Elixir for this?
Let's see. I used debts for something. I don't remember exactly. Storing something on the disk for just configs. Yeah, I didn't want to roll a whole ecto thing for saving my settings, but I wanted them to persist to disk, so I used diskettes for that. It worked well enough.
That's awesome.
Yeah.
You don't have any distributed data synchronization issues to deal with here.
Not so much, no.
Good.
I would have used LiveView if it was available, but maybe that's another refactor for the future.
Yeah. I mean, you could use it for your configuration interface, right?
Exactly. Yeah, you can see it on the fly. Be cool.
Yeah. Cool. Anything else that you want to say about it?
That's pretty much it. Like I said, I've got the GitHub source. We'll put a link and a little thing about the building it. There's all directions here to how to even build the image and stuff. I mostly did it for my own sanity because I don't actually expect anyone to do this, but I might want to do it again.
Totally.
And if you're interested in this stuff, there's a lot of cool discussion in the Elixir language, Elixir Lang Slack, in the Nerve channel of people making cool stuff. So, yeah.
Cool. Just to quickly, on my Lullaby player, a few of the things that I was able to leverage from Elixir that I thought were handy. One of them was using the fact that your supervision tree controls the startup order was useful for me because I would need to wait until, I think it's been a little while, so I'm trying to remember, but I think it was waiting until the sound card was ready so that I could actually adjust the volume appropriately. And I didn't want to move on to letting the controls be active until that was done. So I was able to wait, like one of the early things in the startup is going to just block, and everything after it won't start until it's done. So that was handy. Another thing was just keeping playlist state in a gen server so I know what track I'm on and what track I'm going to play next. And then the other thing was kid proofing it, because if you give kids a thing with buttons on it, you just know they're going to go up and go bang, 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 hit all the buttons and see what happens, right? And so there's a feature in gen server called timeouts, where you can detect a lull in incoming messages. You can say, if I don't get a message for the next however many milliseconds, then fire this timeout callback. So what I would do is whenever I got keyboard input, I would wait to see if anything else came in within the next very short period. I don't know how many milliseconds. And if anything else came in, then I know you're just pushing buttons because you're doing it too fast. And then if nothing comes in, then I'm like, oh, okay, you were serious. You wanted to actually hit pause. Okay, cool.
We call that debouncing in the hardware world.
Exactly. Yeah, I actually called it a debouncer gen server, I think. But,
yeah, perfect.
But yeah, that was a handy feature I discovered at the time in gen server. Elle?
So Rockwell, your thing where you talked about you had to put the lat and long to make the lights go in the right order. There's actually a really cool video on the Stand Up Math channel that Matt Parker hosts. He's a mathematician, where he figures out how to set up a camera and you string Christmas lights through a Christmas tree, take a picture of it as you fire each one, and then figure out from that, almost like doing mocap, where it figures out where they are on the tree, so then you can do 3D designs with the lights. So if you were doing something with lights where you didn't know where stuff was, you didn't have lat and long already, and you didn't want to have to go through trouble measuring it because it's messy, because if you take an LED strip or something and put on clothing, but you're I want the program to know how to light it up in a sweep, you could use this to make it do designs that look correct, even though that it's a linear string of lights.
That's wild. So you're basically, yeah, it's a cool idea. You light up the individual ones and you sort of calibrate.
Yeah, and if you have multi-camera, it works the same as mocap. So if you had multi-camera for a VR setup, you'd already have the camera set up. But if you had just in general, you have a webcam in one angle and the one on your MacBook on the other, you have multi-directional one, and it's enough to like 3D triangulate.
That's a really cool technique. Oh, I thought I saw a hand.
Yeah. I put that.
well-
We're gonna put that in the show notes. That sounds really cool. Sorry, go ahead.
Well, no, I just had a sort of random-ish thought that I'm just still like adjusting to like how many messages and how quickly you can send them. Like when you're talking about like polling at like 60 milliseconds or like sending messages that much, like in my brain, I'm like, how? That sounds like a lot. But it's cool that it's totally fine. It's been running for years on such like a small, lightweight machine, and it's just kind of like not a big deal. So yeah, I don't know. That was just a comment.
Yeah, even thinking about like 50 processes to control 50 LEDs, right? That seems like such a big number for humans, but the beam doesn't care.
Yeah, it's kind of mind blowing, like how many messages you crank through a system and how many processes you can have running. I think we rarely exercise that, to its full potential, because the bottleneck is very rarely how many processes or how many actually internal messages. It's like IO, network request, database, something else. It's not how fast you can pump messages through the beam. So when you're only doing something lightweight like this, I mean, you said the LEDs take a little while to respond, but then you kind of like that all gets hidden by the fact that you've got gen servers in front of them all. Yeah, that's really cool. So the other topic we had to discuss, Zach, you wanted to talk about some of the testing stuff you did on a recent project you were working on or are still working on, I think.
Yeah, sure. Yeah, so a little bit of a switching gears from the hardware stuff. So Rockwell and I are pairs on a current client project, and we've been working on implementing a pretty complex workflow with LiveView. And so we kind of ran into the situation where we had to test this thing. And it became pretty apparent that if we went about writing the test where we sort of did our setup each time, or we just used the sort of standard like has element helpers or like render click in each test, the file would have been like enormous and very difficult to track and understand as a developer. And this was so complex because we had just sort of a lot of different branching points in logic. There's sort of like, are you a new user? Are you a returning unauthenticated user? Are you a currently authenticated user? And each of these funnel into different portions of the workflow. Then you can add and remove some things. You have to fill out some like different forms that can then show or hide based on different states. And there's some validations that can happen, and there's just sort of a lot of touch points all across this flow that would have made writing standard, like the naive way to write tests, kind of difficult to maintain. So what we ended up landing on was sort of, we asked the question like, what if we turned every user interaction into a pipeable function? And we ended up sort of using the view as a sort of token that we pass between each function in the tests. And sort of like what would that look like if we kind of gave this a try? And I think it ended up, Rockwell ended up implementing most of this in this case, but I think it turned out pretty nicely. The tests, and after a lot of sort of set up private functions, the tests themselves end up only being a few lines, and they read very much like pseudocode. That's sort of like, do this thing, fill out this form with these items, assert we're in this particular state, click this button, assert we're in another state, and it all just kind of pipes one after another. I think one of the concerns that we had around that was if we're calling into all of these functions, how can we make sure that we get good messaging if our assertions fail? And I know, I think we just ended up sort of plucking out specific, I guess, yeah, Rockwell, you were like mindful to make sure that the types of assertions that we were making wouldn't just say like expected true got false, but instead would talk more about like looking into the data and telling us like, we got this string, but actually this is what we were looking for, or something like that. So
Yeah,
yeah,
one of the
that's
nice
sort of
things
the high
about
level thought.
Oh, sorry, I was just gonna say, yeah, one of those things about assert is it gives you a reasonable default message, but there's another argument there at the end where you can specify whatever string you want. So you can put a very, very specific reason, like, hey, dummy, this failed for this reason, and here's the expected versus actual values, or that kind of thing. So we leverage that a lot just for future proofing.
Yeah, what's up, Al?
I would agree on that point, Rockwell. On the project me and Nathan worked on, I did the same thing where I was abstracting on the code, and I made sure the asserts had messages that made sense, because like, unfortunately for most of the stuff, we're element probing, and that element probing is going to be Boolean valued. So like, we need to then like put all the context back in the assert message of like, how did we get here if this fails? And for some of them, I even did, because the assert message, if you look at the implementation, is lazy, you can do things that are expensive after the fact in the message when it fails. So like, I would actually rerun like maybe like the parent scoping query to be like, okay, it doesn't have the element, just print me out the whole like sub element HTML so I can just visually look at it and be like, what is missing here in this HTML?
Yeah, that's really cool. I think open in browser is, or I forget the exact function, but the one where you open whatever you have in the browser is also really handy sometimes to do when you see a failure. I've used that a lot in debugging. I think in general, good error messages are undervalued, or like people don't pay attention enough to them, both in test suites, like you're describing the test failure. You get a test failure, you're like, I have no idea why this happened. Or in production, you get an error raised and you're like, this is not informative to me. I don't understand what's happening. Like if you can get an error that you don't understand, then you are behind in trying to debug that. Like I know to me, match error is one of those in Elixir land that's just not very helpful. Like get me something better than that. You can raise a very specific exception with all the information you need if you try.
I mean, isn't match error, at least when you're in IEX, looks really nice now with newer OTP, doesn't it? Because doesn't it break out, doesn't it do the diff for you now with the better error messages? Or is that only on assert? I thought IEX at least, like the thing they had to OTP where we got better error messages, I thought it looked better now. Or maybe that was just function clause.
I'm not sure actually.
Okay.
Maybe my complaint is outdated at this point. I haven't seen a lot of it lately. I was curious, Zach, you were talking about how some of your tests read kind of like pseudocode. Would you be able to just like read an example of that? Or I don't know if anything is to NBA or whatever, but
Let me give me a second and let me pull up a thing and see if I can generalize.
on the fly translate
some
to
stuff and-
non-contractual
Yeah.
version.
So
Yes,
while he's looking at that, I wanted to say that one of my concerns with this approach, which I think has seemed mostly unfounded, but was like writing code to test code. Like a full third of this test suite is just private functions, right? And okay, who tests the test code at that point? Who watches the Watchmen? But it seemed mostly fine because they're private functions and they're all pretty straightforward, and they are tests. So if things are going to break, they're going to break, and you're going to see them. And it seemed like mostly a non-issue, but I was a little hesitant at first to have a whole new body of code to have to like maintain just for the purposes of testing. But it seemed mostly fine. So my concern for that has gone down. Go ahead, Al.
Usually what I do, I'm always reminded of the in the Contact movie where they're like, turn the dish away to see if the signal's still there. And I always think of this of like, when I'm writing complex test code, I start to inject either like a different thing that I'm testing, like a typo, or looking for a typo and making sure the test doesn't pass anymore so that I'm actually testing the thing I think I'm testing. But once I establish it for like the first time I do the helper function, I'm usually not going to look at it again unless the test failed. And then I'll be like, like I kind of changed my level of trust in the code. Like if this becomes unreliable, I'm going to test stuff more of like the test code actually tests what I think it tests. There's been a lot of times what I see when we join a project is they'll just assert a thing, and they're asserting, because like assert takes falsy and true values. And so it'll just be like, when I do this get, and I look up deeply in the structure, it is a thing. But the test says it's like, I get it back and the name is a string. I'm like, you didn't actually test it was a string. That would be is binary. Like, that's one of the things that I see a lot in client projects is they're not actually asserting the thing they think they are asserting. And so they might have false passes for that reason, because it's just like, there is data, it's not nil. It's not that it's actually doing what you think it is.
Why test once when you can test twice for twice the assertions?
All right, so I found a test that I can go through a little bit. So we start with a con, and then we pipe into mount LiveView, which just makes our calls to like render and mount the LiveView. Which then goes into assert phase. Then we pass in the phase that we want to confirm that we're in, which in this case is authenticate. And then we have assert login phase, which is provide email. So now we know that like we've mounted this LiveView and we need to authenticate and provide our email. Then we have submit login email. Then we pass in the email that we are using for, essentially this is where there's a form where you enter in an email and we check to see if the user is in the system or not. And then this is a new user, so then we assert login phase that now we're on the sign up page. So we've gone through this flow of we've entered an email, we've moved to the sign up page, and then we submit the sign up form, which is the next function, which accepts a map, which is the like form data that we're going to submit. And then we have like a follow redirect assertion at the end to make sure that like we've now moved into the next step. And all of that just kind of moves from top to bottom through a pipe.
It's kind of funny
Cool.
because like while you are piping things through all these assertions, because it's LiveView, everything you're doing is actually a side effect, right? You're not actually mutating the thing that you're returning. You're still returning the same view PID essentially, but it is sort of the shared state. It just lives somewhere else, right? So that was kind of a weird thing where you take in the view, you do some side effects, and you just return the view unchanged because you're doing assertions on some other process, which felt a little weird at first, but again, totally works.
Yeah, there's always this trade-off when you're drying things up like that. There's this trade-off that you have to balance between if you have all this boilerplate in every single test, then the boilerplate you can't see the actual what the test is doing because there's so much of it. But then if you extract out everything into little functions, then you sort of have to jump to where that function is implemented and come back to understand what's happening. I think you get in a sweet spot when you've used those functions and you've personally gotten familiar with them enough that you're like, yeah, I know what that one does. I know what that one does. But that's sort of a level of familiarity with the project. But in general, I think like code that makes me not have to jump a lot of places to understand what's going on is one of my sort of internal measures for how clear this is. It's not so much a tooling issue of being able to do that. It's just keeping track in my head of why am I here and why am I looking at this now and what was I doing before this? And the other thing that I find difficult sometimes in tests is when there's implicit setup. I know setup do is kind of an established thing it's definitely an established thing in EX unit. but I personally don't like to rely on that very much, because if I'm looking at a test and I have to go, like, I just have to know that this was done already. I mean, there's a few kind of minimal basic things like setting up the con or something like that, or like setting up the sandbox for the database. That's fine. I expect that to be there all the time. But if there's a lot of specific setup, A, it might not be necessary for every test, in which case it's wasteful, and B, it's like magic to me. So I know I say this a lot, and like most people don't agree with me, but I like to start a test and say, do the setup stuff as a function call. And like, if I want to know what that is, I see it right there. It's at the top of this test. And if I don't need to do it, I won't. When I start the next test.
Yeah, that was a strategy we actually took for this as well, and we did the same thing. And we did actually do it in the setup block, but most of the setup blocks are one-liners, right? They just call into that private function that sets up the thing. And the advantage there is the setup that you're doing, you give it a name. It implicitly has a name, so it actually gives you a little more direction about what actually is being set up. Yeah, El?
One thing I probably wouldn't do for tests that I've used on projects before is like, there are setup blocks, then they become common. Okay, so now they go in the X unit case, like the things that you can share with a use. But you opt into them with tags, and that is like way too much indirection, because even the tools I write you can't click the tag and find the setup block that cares about that tag, because it's not standardized. The tag is just, I set inside of like the metadata, the context we pass in setup, it sets that key to true, or if you do a complex tag, it sets it to whatever you set it to. And so you then have to find the code that is looking for that tag value, but you have to look for it as like, that name colon in like a map match. And so like that's too indirect, even if it dries it up.
Yeah. Yeah, I think the other sort of balance that I think about with testing is that, and I think I heard this from James Gray some years ago. Like, he was saying, the purpose of the test is to increase my confidence in the code. So I don't want to bother testing anything that I absolutely know without a doubt works, and I don't want to spend more time on the test than has a payoff for me. So there's that like cost benefit, and obviously we want to test our code really well. There's some things that I'm going to test the living heck out of, because, like, for example, I've been writing some key set pagination code for GraphQL, and like constructing those queries and like making sure that every possible way that you can paginate, every possible set of parameters you can give it, it all works. I want to test every single combination of that, and I think that I need that for the confidence that it gives me. But this is always a bone of contention. But for me, Dialyzer has been one of those like more effort than payoff by far. I spent almost all my time fixing the specs and almost none of the time fixing the code. It's like, why do I have these specs? I don't need to have specs so that I can fix specs. Like, this is useless to me. I understand it's like good documentation, so I'll do it for that. But I'm growing more and more convinced that I don't want to actually be wasting my time fixing these things, because it doesn't help me make better code, in my opinion. El?
I would say, one, I agree with you. I'm all for Dialyzer just because I don't want my specs for the docs purposes to be wrong. But for it point out code problems, no, not really. I really wish it was just faster. Like, it needs to keep track of why it got to this decision to tell me what one thing to fix so that I can fix the docs. Like, there are a few times in small libraries where it's like told me like, oh, because I did this with, I have both like an error with a tuple and just a bare error, and that's probably a bad API design. That's the other place where it's helped me, because you probably want one form or the other. But in general, like, it actually catches a bug. Yeah, I agree. Then I had another thing for the part that you said before Dialyzer. What were you saying before the Dialyzer part?
About like what you choose to test. Like,
Oh, right. Okay. On that point, I was going to say that I'm very for like the test is flaky. That means it must not have value. Therefore, just get rid of the test. Don't try to make it not flaky. Because if we're ignoring that as flaky and just retesting it, we're just getting it to pass, and its passing means nothing. Like obviously, there's caveats of like the authorization test is flaky or the security test is flaky. That's be concerned, be very concerned. But like a lot of them were like it's just flaky because it's really hard to predict the IDs, or there's a race condition in like an interaction with another process, and it's not a security concern. Like just take it out. You're spending way too much time trying to make it not flaky.
yeah, I agree. Benny?
Oh, I was just curious about your API testing when you're setting up GraphQL. Do you like to test the functions like data in, data out, or do you like to test HTTP requests like a request spec or a little of each? And it's kind of like in terms of the test being ignorant of the internals of the code and just sort of hitting the surface area like a client application would.
Yeah, so for our GraphQL API, we're doing almost entirely request tests because that's what users are actually going to do, and that's what we want to prove works. And
that's what I was hoping your answer would be.
Yeah. And I think in general, like when I was in the Rails world, which has been a little while now, I think we tried to do less request testing because it was just didn't perform as well. But on Phoenix, it performs so well that I just lean towards doing that almost for everything. The only thing that I'm doing any other kind of testing on is the key set pagination code because I want to test it a little more generically, I guess. It's not so much about how it parses the documents because all it's really doing is modifying an ecto query based on some parameters it gets. So I test that more at a function level. But in general, I think an API, you want to test it at the request level, in my opinion. Oh.
So I assume you're using Absinthe for the GraphQL. So did that feel like that was the normal choice in the Absinthe community, or was it like a thing you had to pick one way or the other and you picked request?
I absolutely have no idea. I think we just did it that way. Gustavo actually kind of led the way on that because on this project, he was the one who came in with the most GraphQL experience. And we had a stage of this project where we're like, okay, we've decided for various trade-off reasons that we want to use GraphQL in this, but none of us actually know GraphQL. So we're all going to go off and build toy apps for a few days, and then we'll show each other what we came up with and try out the features we had. And Gustavo's toy app had the best features in pretty much every respect, including the way he tested things. It was really nice. I'm not even sure if I tested at all in my toy app. I was just tinkering. But we were all like, yep, let's do it like he's doing. What do you want to say, Gustavo?
Yeah, I got this way of writing tests from the book, this Absinthe Elixir book. So every chapter they create new features and add the test. So I just copy the font. Yeah.
Cool. Yeah, it works out very nicely. And Absinthe has this, GraphQL has this concept of like, here's the document that describes the request I'm making, and then here are the variables that I want to plug into that. So, searching for a username, the document stays the same across different searches. You just plug in different variables for who you want to search for. And so we have it set up like that in our test, where here's the document, and then here's the variables, and now make the request and then verify what you get back. We're not totally happy with our setup on documentation, but it's kind of okay. We're using Bureaucrat, which is like an Elixir tool that lets you run request tests and add a description to them, and it'll output Markdown, which you can then obviously serve as HTML. And so we're running our GraphQL test through that as well, so that users can see if I pass this document with these variables, then I should get a response that looks like this. it's okay. Trying to munge that together with the type docs and everything has been a challenge that our lead client developer has pretty much been the one to tackle that part. Go ahead.
I'm kind of shocked that I remember we used Bureaucrat on other projects that weren't GraphQL, so it seems very like not GraphQL specific. I'm kind of shocked that like with graphical and stuff like that, that there isn't a GraphQL specific one that would make it much more like just here's the GraphQL doc, because Bureaucrat like records the HTTP headers and stuff like that. That it seems too low level and too detailed to be necessary.
Yeah, it's not a perfect fit. It's the best we came up with so far. We may change at some point, but it works okay. But we do have Bureaucrat does give you a way to write some just human documentation as an intro to the generated docs. And so in that, we explain a few things and give a few examples. And we also say, and also click here to go over to the graphical. Graphical is, if you haven't used it, it's like a little JavaScript page where you can write queries. It'll help you like autofill based on the types it knows about in the system. And you can click the type docs and see, oh, the username is a string and the ID is an integer and this input has to be a Boolean and all that stuff. So from the docs, you can click through and actually try out examples against the API. That's pretty handy, but I agree that it would be nice to have a documentation tool that's more tailored to GraphQL. I just haven't seen one yet. Another time, maybe I'll try to prep some other things we've learned doing GraphQL. It's been overall, I would say it's been a positive experience, but there've been a few gotchas.
Yeah, that may be helpful. My current client is for the two versions of the API. Old one is, hand-rolled serializer JSON, not even, JSON API, and the new one is going to be GraphQL. And so having more guidance of, is this a good idea, would be helpful.
Yeah, I would say the biggest. Go ahead.
Not like just the switch to like they have mobile clients. Like it makes sense to use GraphQL, but in the sense of like how they're using GraphQL or how they've decided to structure their pagination, which I know is very flexible, in GraphQL, like if all the decisions they're making are good decisions.
Yeah. There's some things that aren't really standardized that we had to make decisions on. It was like we picked the relay pagination style because it's more or less standard, but it's also a little bit cumbersome in our opinion. But yeah, that's what people are going to expect. I think probably the GraphQL is like a two-edged sword because the benefit of it is clients can ask for exactly what they want and get exactly what they want. It's super great for them. But the downside is they can ask for exactly what they want and you have to anticipate that. And so like, what if they ask for way more data than you really ought to give them in one request? And then you have to like figure out how to do the complexity analysis and well, how many association records can we reasonably expect them to be getting with this resource? If you get a user with all their posts, is that going to be okay? How many posts do users have? If users have 10 posts, then that's fine. But what if one user has 1 million posts and then it's going to blow up that request? And then what do you assume when you do the complexity analysis? And anyway, that I'll talk about that on another show. Cool. Anybody have anything else on the topics we've been talking about, or anything you want to bring up? Awesome. Well, thank you for joining us on Elixir Roundtable. Thanks everybody who's on the call, and thanks for all our listeners for paying attention. We appreciate you. Take care.
Thank you.
Thanks, all. See ya.
Thank you. Bye.
Should have stopped recording. It hasn't stopped recording.
I still see the red light.
Oh, let's just hang up.
Okay, bye. No, you hang up first.
I'm afraid if I hang up, it won't record. Stop recording. I have no jokes for you or anything. Stop. Stop.